So we will continue with our next presentation. So Emin will be talking about the optimizing supply chain efficiency. So Emin, if you are ready, you can share your screen, and yeah, stage is yours.
Okay, hello everyone. Let me share my screen. Oh yeah, here. Okay, can you see my screen?
Right, it is visible.
Okay. All right, then let's get started. Hello everyone. I'm Emin Mohammed Eraydın, and currently I'm working as a staff data engineer at Blue Yonder. And today I'm gonna talk about supply chain efficiency, and my speech will relate about data engineering stack and what we are doing as a data engineer at Blue Yonder. Okay, let's first check the agenda. So first I'm gonna talk about myself. Then I'm gonna give you some short introduction about what supply chain is and what are current challenges. Then I'm going to talk about my company, Blue Yonder, and our role, data engineer's role at Blue Yonder. And in the last part, I'm going to talk about some technologies, and we have some data engineer related technologies at Blue Yonder, and these are some of our open source, these tags developed by Blue Yonder as a open source technologies. And also we have some internal tools. So also I want to talk about those, and I'm sure this will give you some perspective. And I believe this is one of the important things for this kind of events. And let's start with me. All right, I graduated from Istanbul University Mathematics, and just after that, I started my career as a big data consultant at GTech. Then I worked as a data engineer at EasyCo, and gitti gidiyor. eBay Turkey was my last company in Turkey. So after eBay decided to close their operations at Turkey, they closed the gitti gidiyor, and I got a job offer from Germany. And me and my wife and our cats relocated to Germany. So for now, we are living at Germany, southwestern side of Germany. So for almost 2 years, I worked for Bauhaus, and for last 2 months, I'm working for Blue Yonder as a data engineer. And yeah, let's get started with what is supply chain. So let me give you a short definition about it. So just think this supply chain as a network between producers and consumers, and it's a huge network. This network also has a lot of sub-networks, and all of these sub-networks needs to be solved in different way. That means you are not able to create a one single huge product to solve all supply chain problems. Most of the companies create some specific problem on supply chain. They create some specific products for specific problems. But at Blue Yonder, we have different products for almost all supply chain problems. So that's why we have a lot of experience with supply chain. And after that introduction and definition, of course, supply chain has some challenges, and we are trying to solve these challenges. That's what we do. And these challenges is mostly like delays, high costs, inefficiencies, and it's like there's something with supply chain. It affects everything, and it affects every pricing on your life. Like if you want to buy something from a supermarket or a tech market, if you want to buy a phone or bread from supermarket. This is all related to supply chain. So if your service providers use efficient supply chain, that means you will be able to get those products in a cheaper way. And that means supply chain affects everything, and it's a huge part of our life. So efficient supply chain means we will have cheaper goods, and that's what we are trying to achieve. So after this introduction, let's talk about challenges. So this challenge is just specifically for data engineering and data science, and it's also similar to other challenges on other problems, like not specific problems for supply chain, but of course, collecting data and data processing is always a problem if you try to handle a huge amount of data. And also IoT, AI, machine learning, data analysis, these are outcomes of our collected data and processed data. These are also another challenge in our data work. It's also related to our problems in supply chain. And of course, if you are trying to handle huge amount of data and if you are trying to get information, and if you are trying to process this data, you have problem with scaling and performance. And of course, these last two are another problem in our work field. So what does Blue Yonder offer, which is my company? We have solutions almost every supply chain problems, and I'm gonna talk about my team today. So I'm not gonna give you all details about Blue Yonder. I'm just gonna talk about my team and what we are trying to do and what we are trying to achieve. And Blue Yonder at a glance, it's a US-based software company. We have offices all over the world. Currently, I'm okay. So you need to fulfill it. You need to provide and you need to send correct product to correct store. And in order to do that, you need to decide every day or weekly or 21 days. It depends. It's configurable. And we are trying to solve this. So every day or every week, our customers provides inventory data to us, and we are deciding which product should go where. And in order to do that, we are of course considering about the weather, the day, if it's a special day, for example, if it's October, you can expect that there will be a lot of beer consumption in Germany, etc., etc. So we are also looking for some special events. And of course, we have another tool from different team, also it's in Blue Yonder, and they are forecasting the demand. And this demand forecasting another input of our product. So we are getting all of this data and deciding how to distribute your inventory. So we have two different units under this team, scaling, optimization, and UI. So I'm part of scaling team. So we have 5 developers, and we are trying to solve data engineering related problems. Optimization is our algorithm team. So they are core team which decides this algorithm, and they are writing it. And also we have a UI team. And of course, we are providing software as a service, and we have a UI for that in order to provide a user-friendly product for us, for our customers. And also we have a UI team. And let me give you a short introduction about tech stack. So as a scaling, we are mostly working on Python. in optimization, they're both using Python and C++. So main core algorithm runs with C++, but we have planned to switch to Rust. And also on scaling team, we have planned to from Python to Java. Okay. So as you can see here, it's like a different steps in the supply chain. And if you see this red circle, that's our team. So we are working together with demand forecasting team, and we are the replenishment team. Also, we can call us our replenishment. So there's a lot of different steps, and all of these steps should be solved with a different product or different model. I mean, it's not possible to solve all of this problem with one single model. They're all different problems. So that's why you need to specifically work on all of these problems, because all of these they're unique, and it's not possible to provide the one single solution for all of these problems. And let's move. So let me give you some highlights. So what we are doing and what is our data size. Then I'm going to give you some details about what we are using and how we are distributing and partition data, etc. So 650 million orders per day, and orders mean products. So we are deciding for 650 million products every day. So this is just daily job. So that means for this amount of data, we are deciding which of these go to where and which store, which shelf, etc. I'm just talking about supermarket, but also it's possible to do this for tech markets or similar things. So the algorithm works same. And also this for quarter, if you sum up 58 billion orders per quarter. So it's a pretty huge data. It's a bit problematic and challenging for both data engineering side and data science side, because you need to be able to handle this huge amount of data. And of course, we are using 500 million forecasts in 10 minutes on one system and 7,000 billion predictions in Q2. This numbers still similar, I hope so. So that's why I use those numbers, but I'm sure these are still similar. Okay, so what is our role at Blue Yonder in a supply chain efficiency company? So as a data engineer, we are responsible for data platform management. So we have a huge data platform. We have a lot of different repositories and thousands of tasks and hundreds of pipelines. So we are able to manage all of them. And also distributed and parallel processing is another huge problem for us. So we need to also solve that. As you can see in the previous slide, there's a lot of data to process, so we need to handle all of those. And of course, pipelines is like a standard job for data engineers. Data governance is a big issue. So since we have different customers from different work fields, like manufacturing and supermarkets, also data governance is another problem. It's hard to keep same data standards. So that's why also we are trying to handle those data governance stuff. And of course, CI/CD for our optimized and efficient development lifecycle, and ops. So we have some ops shifts in the company. So sometimes we are working for not only for weekdays, sometimes weekends, but it's just tiny things. So let's jump to the technology. So in here, you can see some unique stuff like Kartotek and Plato, Turbo DVC and Stratosphere. I'm going to talk about those in the next slides. but let's start with platform. So now currently we are using Microsoft Azure as a cloud service provider, but we are not hardly dependent on cloud providers. So it's just my opinion. We are mostly using Kubernetes on a cloud provider and some file systems. But other than that, all of this stuff, data processing and other stuff works with our open source technologies. So we are using Microsoft Azure and of course Airflow for the pipeline orchestration. And we are using Kubernetes to run everything. So all of our clusters like Dust clusters, our other data processing tools or any other things runs on Kubernetes. Stratosphere is an internally developed tool. It's like Terraform, but it's a specific Terraform for our use cases. Like you need to configure a YAML file like you did on Terraform, but since it's specially developed for Blue Yonder, like we have some specific tools like Dusk clusters or Azure Key Vaults. In order to deploy those, we have some predefined modules, and we are using those, and we are creating a individual platform for each of our customers. So that means we have separated instance for all of our customers, and all of these individual data platforms, all of these separated architectures runs on Stratosphere, and also all of these orchestrations runs with Stratosphere. It's pretty straightforward because it's developed for Blue Yonder and developed by Blue Yonder. And for data management and processing, most of data processing runs with Snowflake. So for pre-processing and post-processing, after data prepared, we are putting data to Snowflake. For data execution, we are using Dask, and I'm sure you want to ask why Dask. I'm going to answer this question a few slides later. And we are using Kartotek Plateau for data processing and data storing. So it's also an open source technology, and Kartotek developed by Blue Yonder developers. And TurboDBC is also Blue Yonder's open source product. I'm going to talk about it. So it's our overall architecture. So it's almost 20 minutes, so I'm going to do it fast. So basically, we are getting data from our customers, and we are getting demand forecasting from another team of Blue Yonder. We are putting all this data together. We are generating data for our optimization team, and they run their algorithm. This algorithm reads data from Snowflake, prepare everything, and writes this output to Snowflake again. And with the API, we are providing this outputs to our customers. So this API basically reads data from Snowflake and provides this data to our customers. And all of these systems runs on Stratosphere. All of these orchestrations runs with Stratosphere. Let's move with platform. So in a bit detail, we are using Kubernetes, everything running on Kubernetes. We are using Azure Blob as a file system, like our Kartotek and Plateau implementation is a file system, and you can use Azure Blob S3, Google Cloud Storage, or your local machine. It's pretty straightforward. And also we are using Azure Key Vault to keep secrets. So we have a lot of secrets to keep. So a lot of credentials because we have a lot of customers. There's a lot of different configuration for that. So we are also using Azure's Key Vault in order to keep these secrets in a safer way. And Stratosphere Airflow. So let's jump to the Stratosphere. Like I said, it's internally developed, and it navigates the complexity of Azure, Kubernetes, and Blue Yonder. So it's pretty easy to deploy something on Kubernetes with Stratosphere because it's predefined. If you want to deploy a Dask cluster, you just need to configure it. It directly deploys your architecture to Kubernetes, and it just prepares in a few minutes. It's pretty easy and straightforward. And also it provides you high availability. And most important thing, it reduces infrastructure costs because it shares this. For example, we have lots of customers, and some of our customers' resources is not necessary for one of our customers anymore. We can use this resource for other customers. So we are sharing this resources between customers, and this reduces infrastructure cost. And this is one of the most important outcome of the Stratosphere, and also it navigates the complexity. I mean, it's internally developed platform, and it's only available for Blue Yonder. But I just wanted to share that with you because it may give you some perspective. So we are also handling this Stratosphere. So we have the source code, and we are able to change some error handling or do some custom stuff. So we have a lot of flexibility. So of course, in the first few months, it's hard to develop this kind of products, but after that, it gives you a lot of flexibility. Let's jump to do data management and processing. So like I said before, we are using Snowflake, Dask, and Kartotek Pilot and TurboDBC. So let's talk about Snowflake, and next slide, I'm gonna deep dive into Dask. So for now, we are also using Azure Blob as a data storage, like our Kartotek Pilot implementation needs a file system, and we made changes in the future, and we have planned to switch our data storage strategy to Snowflake. But for now, we are using both Snowflake and Azure Blob. And we have different use cases for Snowflake. And end of the day, we are trying to create a huge Snowflake data source for our customers, and they will be able to access data from the Snowflake. So we are trying to provide a huge fulfillment solution via Snowflake. But let's jump to the Dask. So like I said, you can ask why we are using Dask. So this decision has been taken like 6 or 7 years ago, because they took this decision to Blue Yonder because there was a lot of Dask contributor in the team. So our previous Blue Yonders, our previous colleagues were part of the Dask community, and they were part of their Dask contributors. So they had lots of experience with Dask. So they started implementation with Dask, then they developed Kartotek, and we are using Kartotek most of the fields in our system. So Kartotek uses Dask. So now we are using both Dask and Kartotek, and it solves problems pretty cheap and fast. So there's no need to switch to Spark for now, but in the future plans, we have planned to switch to Java. But for now, like we are able to process 650 million products a day with Dask. And in order to do that, we have 500 plus Dask clusters. I mean, each of our customers, we are creating individual architecture for each of our customers, and they all have their own Dask clusters. And in total, we have approximately more than 500 Dask clusters. And also it's pretty good tool to utilizing our subscription and auto scaling. And for stability and resilience, it's pretty old tool. It provides some standards and functionality to you. And it is pretty good with Apache Parquet files, which we are using in most of our implementation. So most of Apache Arrow and Parquet, most of our implementation works on Apache Parquet and Apache Arrow. And the Kartotek Plateau, I'm sure these two are to most of you, maybe all of you. And because Kartotek and Plateau, they both are open source, so you can just get it from GitHub and you can use it. And it's a Python library especially developed for the Legionnaires needs, but also you can use it. So it uses Apache Arrow and Parquet, and under the hood, it executes everything with Dask, or also you can execute it with Python pandas data frames. So it has a different functionality. So if you want to get a data set as a pandas data frame, you are able to do it. And also you can do it as a Dask. So just, you can say return by this Parquet file as a Dask data frame to me, then you can also execute this file. And also it has some different functionalities under the hood. But it's basically uses high partitioning. I'm not sure you know about high partition, but let me just give you a quick example. In a high partitioning, just imagine you have a table, and this table like orders. In the high partitioning, you have a folder named orders. And you just need to decide which field you want to partition your data. So let's say you want to partition your data on database with a date field. And under this orders folder, you have different folders for each of these days. So for today, you have a subfile, and all of today's data will go to this subfolder. And you will have another file for tomorrow, and it will go like that. So this is the idea of high partitioning, and Kartotek and Plateau basically uses this one. And this architecture provides atomic updates. Like if you just wanted to change something on a specific data, you don't need to read all the data. You just need to get this specific partition, and you will just put this specific data to memory. You're gonna run some updates and put this data to, again, same folder. Or like it's also a case for us, like if we want to run our, for example, if you want to run your algorithm for 21 days and for just one specific products, if you design your partitions in that way, you don't need to read unnecessary data, and this will work very fast. And even you can do this with pandas data frame easily. You just need to design your data wise way, or you just need to design your data structure very well. And if you did this, I mean, you are able to get only the necessary data, and that's it. And with this architecture, we are able to run, we are able to execute and get a decision for 650 million product orders each day, thanks to Dask and Kartotek Plateau. And Kartotek is the first version of this product. First, it released as a Kartotek. It was a Blue Yonder's product, but Plateau is, I think it's part of Data Engineer Foundation. So we just switch from card detect to piloto. These two tools are same, just name change. So developers, they're all same. There's some just syntax changes. Yeah, it's from data engineering collected. There is the link. So if you want to use it, just do not hesitate. Just download and use it. And let's go to the TurboDC and TurboDBC, and this will be my last text to talk about it. So it's basically C++ to Python API transition. So it's specifically developed for reading NumPy arrays. So it's a pretty good tool for the data science projects. So basically, it reads data as a C++ and provides this data to your Python API. You can also get and install this to your Python environment. It's also open source. We are currently using this in production. It's pretty user friendly and it's good with NumPy arrays. And okay. I think, yeah, if you have questions, I can take it.
Thank you for your presentation, Emin. If anyone have a question, you can type or raise your hand. Okay, I have a question, Emin. So, as I see, probably you have lots of, maybe hundreds of pipelines in your day-to-day work. So how are you probably you are building integration into the customer systems or internal system. Maybe probably there are lots of different systems. And how do you maintain these pipelines? Do you have an internal implementation? Maybe when something fails, when there's an issues, how do you managing this process?
Yeah, of course. I mean, we have separated the Airflow instance for each of our customers, and we have different tasks for each of these customers. And also we have a ops implementation. So if something comes up, if some error comes up, we are receiving SMS if you're on the shift. So it's called shift. So if you are on shift, you are responsible for handling these errors. But of course, in our implementation, we are handling these errors. So if something comes to Kibana or Elasticsearch, these logs are directly going to our Elasticsearch and directly goes from there to Kibana. So we have some rules. If some of these rules triggers, we are getting SMS or email, and we are directly looking into it. It's something like that. Yeah.
Got your alerting system.
Yeah.
Got it. Perfect. Okay, so if there's no question, we will start with our next talk in 10 minutes in 5:20.